Hey, Pat and Chris here, back for another episode of Shop Talk, diving in further on Rangers. Chris, we talked about engines and clutches already. What are we going through today?
Well, we talked about step one, which is how you make the power. Then we talked about how we transfer that power with the clutches. This whole episode is going to be about driveline. So what are the rest of the steps of getting power to the wheels? Pat's going to give some pretty detailed explanations on how some of these parts work. We're going to talk about what that means on the trails and the different drive modes you should be in. We're going to talk about some quality improvements we made. But you guys should finish this episode with quite a lot better understanding of how a Ranger driveline works. And it should be pretty informative.
Yeah, and we've got some actually older parts on the bench here today, or stuff from maybe some other models that aren't exactly the one we've got. So Chris, let's go show them where some of this stuff is on the Ranger, and then we can come back and kind of dive a little deeper on, what it looks like on the props we've got on the bench today.
So this is the rear differential. That's connected to the transmission, and that's where it gets power. And the rear differential transfers power to the outside wheels through these bars right here, which are called half shafts. And those half shafts are able to articulate with the vehicle, and they provide power to the wheels. The basic function of this differential is it can either lock those two rear wheels together so that they spin at the same speed, or else they can unlock so they can spin at different speeds. We'll talk about why that's important later. So on this Ranger, we took the front bumper off because it just makes it easier to see. Pat will move it out of the way for us. This is the front differential. And so the front differential is kind of similar to the rear differential in that it controls the power to the wheels. But the real job of this front differential is to determine if the front wheels need torque from the driveline. And it's really in charge of delivering that power to the front wheels. So those are the big parts of a Ranger driveline and where they're at on the vehicle. So Pat, why don't you start with the rear differential, maybe describe some of the main parts and show us how it works.
Yeah, absolutely. So we've got the input shaft on the transmission right here. So as this shaft spins, basically when the clutches would be spinning, you can see a few things going on the outside. So if you look down here in the back, you can actually see that this output shaft, this is what would go to that half shaft to spin the rear wheel. That's also spinning. The other thing you see is this snorkel tube gear that's actually powering this shaft. This is what goes on the prop shaft up to the front drive. So pretty much any time the rear wheels are spinning, the prop shaft should also be spinning that powers the front end, whether you're in all-wheel drive or not. There's also a couple other shafts in the front of this that really dictate how your high, low, reverse, and park work. And then the shift sectors on the backside, guys don't really need to worry about that today, but that's how you shift between the different gears. The other thing I should talk about here in the back is the differential. So anytime you see this big solenoid mounted on the back, that's how you know that gear case has got a rear diff where you can unlock basically the back end. So when this gets energized, it actually moves a little rod inside and it allows these two outputs to spin independent of one another. So Chris, why is it good to have that turf function on a Ranger? Because on most Razors, it's a lock spool. Both rear wheels are spinning all the time.
Yep. So on Rangers, we use what we call a turf mode rear differential. And that means that as a consumer, you've got the option to either lock your rear wheels together or you can unlock them. The reason you want to do that is if you're driving on your yard and you need to go on a turn, your outside wheel has got to travel a further distance than your inside wheel. So if those two wheels were locked together, the inside wheel is going to skid a little bit and you're going to tear up your grass. That's specifically why we call it turf mode on a Rangers, because when you're driving on the grass, you only want to power one of those wheels so your rear wheels can operate at different speeds and it doesn't tear up your grass. The other benefit of having an unlocked rear differential is it also can make your turning radius tighter and better. That can be really important, especially on a crew vehicle like this, which is really long. And you can tell this one's set up for going hunting. So if you can imagine driving through really tight trees, wooded areas, you need as much turning radius as possible. And when your rear differential is unlocked, you can turn the maximum tightness in a turning radius.
Nice. So, imagine that there was a prop shaft coming up to a front drive. We actually borrowed one from the Razor guys that we had around here, but it gives you an idea of kind of what the isolated style of front drive looks like. The configuration on this one's just a little bit different, but you'll kind of get the idea, right? If you look at these big mounts on here, this Ranger behind us would have one kind of up in the front and one closer down in the back instead of the two at the top. But otherwise, it's a pretty similar differential style. So Chris, what's really the benefit of that isolated mount, on the Ranger application now?
It's pretty simple. These are basically just rubber pucks that mount the front drive onto the frame, and they just absorb any vibration that you're going to get. So as Pat talked about, that prop shaft is always spinning anytime the rear wheels are turning. And when that turns, it can create vibration in the front end. These little pucks, or the engineers call them isolators, can isolate that vibration from the frame and just make for a smoother, quieter ride overall.
Yeah, and that's, I think, especially important when you got a full cab unit, right? Like on a North Star,
Yep.
where that noise really gets amplified on the older units and the new ones. It's great, you know?
Yep.
The other thing we've got is actually an older solid mount drive here that we've actually split the two halves apart to kind of show you what some of the pieces and parts are that go on the inside. So if you look, this is actually the input shaft that I'm spinning with my fingers here. And if I pull this, a couple of these other parts out, what you'll see is how the ring and pinion is actually set up. So you can see there's a gear on the input that connects to the gear right here. And hopefully you can see in this film, in the screen here, but there's these little profile wedge areas on the inside of this ring gear. And if we drop that back down in the gear case with my now oily fingers, you know, we took all these roll pins out already, but these would normally sit inside all these cage windows. So what you see here is that there's kind of two sets, and one of those is basically for each side. So one's for the left front wheel, one's for the right front wheel. And if you look, hopefully you can pick it up in the camera, but when I spin the hub, hopefully you can see that inner portion actually spinning inside when I spin this side, and the bottom one staying stationary. So what happens when you energize the all-wheel drive, when you flip that switch up, it's actually going to create an electromagnet in the back side of this cover where the wire goes in with a little bit of a drag plate. That is basically going to then allow a little bit of drag on this cage that's going to allow these rollers then to pinch between the output hub and that profile you saw on here. So the reason that it's kind of cut like a V is one direction's for forward, the other one's for reverse. And this spring and this part right here, basically when you flip between directions, like when you shift from low to reverse or reverse back to low, we actually turn this off and back on, and this spring is what allows it to pop back to the center position so it doesn't jam up on you, or wedge we call it. So as you look at this thing, it works kind of like an overrunning clutch, where when it's energized and all four of your wheels are spinning at the same speed, like you get nice, light, easy steering effort because it's like you're in two-wheel drive because it's not actually transferring power up to the front end. It's not until those rear wheels start to slip a little bit that it actually mechanically engages, rocks this cage into that profile that we talked about in that big ring gear area. And that's really what locks the front wheels into that shaft coming in from the input.
Yeah, and we should maybe dive into that and simplify it a little bit, because I think it's a really common misconception that when you're driving in a Ranger or really any Polaris product, you flip it into that top switch, that all-wheel drive. A lot of people think, well, I'm in four-wheel drive, they're all locked in. And that's really not the case. And it's not the case, but that's really beneficial. Because in a lot of off-road vehicles that have a front differential that you turn on and then it locks together, there's a lot of downsides. It can make the vehicle harder to steer, and it makes for a less comfortable trail riding experience, or really any kind of riding experience. But the real benefit with the Polaris on-demand all-wheel drive system is, to the point Pat made, it's only going to provide power to those front wheels when the front wheels need it. And can you explain, I think they call it underdrive, right? Can you kind of explain how that works? You mentioned that as long as all four wheels are traveling at the same speed, the prop shaft isn't providing torque to through the front drive to the front wheels. How does that work?
Yeah, so the way that works is that the front wheels actually spin just a little bit slower than the rears do. So as you're going down the trail and you're in, say, a hard-packed terrain, like say you're on, you know, a gravel area or something that's like, you know, dry, hard earth, and all four wheels literally are spinning the same speed, basically the rears are doing all the work. So the front end is kind of along for the ride, even if it's energized and ready to go, so to speak. Once you go into a corner, or let's say you hit, you know, some more technical spot where the front end needs to maybe climb up and over a log or do some work for you, as it starts to slip in the back end, that's when this roll cage really, it mechanically moves just a little bit to pinch these pins up into these areas in the roller, and then they push against the output hub. And at that point, what you see is that this whole thing moves, and you can see those output splines going too. So yeah, it's a pretty ingenious system in the way that this setup works, because when you don't need to transfer the power to the front end, it doesn't really do anything, so you get nice, easy two-wheel drive steering effort. But when you need the front wheels pulling, they lock in both sides, and you do have a little bit of differential, so when you go around a corner, you're not fighting the front too bad. So yeah, it's a really nice setup for sure.
Another really common misconception, we'll talk to people at shows or I'll be out with hunting buddies that don't know as much about how a Ranger front drive works. A lot of people think there's a bunch of fancy electronics and technology in the front end that sense the wheel speed and it's a supercomputer, or there's something really fancy going on in the front end. But as you mentioned, it's really just a mechanical system. It's just based on the wheel speeds and an underdriven front drive ratio that allows the vehicle to sort of sense if it needs the front end to help or not.
Yeah, absolutely. And there are some smarts inside the electronic in the engine controller that will prevent this from being engaged. So like, you know, if you got a guy out on a frozen lake ice fishing and, you know, they're maybe driving a little more aggressively than they should and they flip that switch while the back ends, while the rear wheels are spinning, we'll actually wait to energize the front drive so it doesn't get a big shock load going through it that could damage it. So yeah, we do wait until it's in a safe condition to energize that coil. Which generally is, you know, slower speeds, slower engine speeds. But once it's energized, yeah, it can kind of turn on and keep the front wheels working as much as you need them to. So yeah, it's mechanically, you know, kind of like, you know, rotating itself in to lock, you know, the ring gear to the output hubs. And then once you're done, or, you know, you shift direction or you have a torque reversal, then it automatically turns off basically.
That's really cool stuff. Now, one thing you talked about is how one part of the front drive can help provide power to the left side of the vehicle, and one part of the front drive can provide power to the right side of the vehicle. So does that mean that when you're in all-wheel drive, you've got your electromagnet engaged, do the front end, do they lock together? Do both wheels spin at the same time? Or how does it work, and what's the benefit of the Polaris system?
Yeah, so they generically speaking, I'll say, do lock together. So if you look at how deep this profile is in this ring gear, you can see that it spans all the way across this cage. And in that, you know, when you lock both sides together, it can rotate and lock both of the output hubs at the same time. But when you start going around a corner, kind of like we talked on the rear differential, there is allowance for a little bit of slip that can occur to let those front wheels move at a little different speeds because these output hubs are independent of one another. So you get a little bit of that even when you're in all-wheel drive to help pull you through the corner, and it's not fighting you so much like it would on a full kind of one-to-one like your pickup truck when you're locking in 4-low. But most of the time, whenever you need it, it automatically pulls, you know, all four wheels at the same time. So both fronts will engage and help pull you through. It's not like you need one to spin up and then let the other one engage. They'll both come on at the same time.
That's pretty cool stuff.
Yeah.
Let's talk about how this might work on the trail. So you mentioned even when you turn on the all-wheel drive switch, the prop shaft is spinning, but the front drive's still not providing power to the wheels. Let's say we're going down a hard-packed trail, like some gravel, and you come up to a mud hole. So you get into that mud hole and the rear wheels start to lose some traction. They start to spin. What happens from there?
Yeah, I mean, the front end basically will rotate in, automatically lock the hubs to this ring gear, and then pull all four wheels so it'll get you through that obstacle.
And you don't have to press any buttons. You don't have to flip back and forth.
No, I mean, when I'm trail riding, I usually just throw it in all-wheel drive and drive down the trail that way. That way I don't have to worry about stopping, engaging four-wheel drive or all-wheel drive. You know, it's a lot different than your pickup truck, right? Yeah. When you're out in rough conditions, say it's snowing outside here in the Midwest, right? Like, you don't want to tear up the front drive by locking it in the whole time you're driving. You wait until you get to that bad spot, then lock it in. Well, on these, when you're on the trail off-road, you can literally flip it into all-wheel drive and drive that way all day, and the machine will just be ready for you when it needs to be.
That's awesome.
Yeah.
Now, the one thing to remember is when you're going to be driving on your grass, that'd be the one situation where you do want to get out of all-wheel drive, because in all-wheel drive, your rear differential will be locked together. So if you go out on a day of trail riding, you get home, you unload the vehicle from the trailer, and you pull it out into your yard, that's the one case where you want to make sure that you're flipping into turf mode so that you don't tear up the grass, or you might get in trouble like I think Pat's pretty used to at home.
Yeah, absolutely. Well, Chris, is there anything else that we got to talk about, you know, as far as driveline stuff goes today?
No, I think those are really the basics, and that's what we wanted you guys to take away from this video, is that you don't have to switch between modes while you're out trail riding. You can put that vehicle in all-wheel drive, and this system, while it is pretty simple, is ingenious, and it really can adjust to what's needed, and it can provide more torque to the front end when it's needed, but it's not going to make your steering difficult like a lot of other four-wheel drive vehicles, and that's the real benefit of a Polaris system.
Hey, we just covered a ton of content on Ranger Driveline, how transmissions work, how front drives work, probably way more detail than anybody really needs to know. But I think that's going to wrap it up for this episode of Shop Talk. Chris, what else do we need to tell these folks?
Give us a comment. Let us know what you thought of the video. If you liked the video, like it. If you didn't like the video, leave us a comment and tell us why. Give us some recommendations on more content that you guys would like to see in the future. Thanks for watching.